on the notes that we took yesterday. So yesterday we started, we did some review of some basic geometry type stuff, talked about some terminology. We talked about angles that are in standard position. Remember, they start with the initial side on the positive side of the x-axis, and then do we go counterclockwise or clockwise? Either one. Counter is positive, clockwise is negative, measured from that position. And then we talked about coterminal angles. What were coterminal angles again? They end at the same spot, but they have a different measurement. They end at exactly the same spot, but they have a different measurement. And how far apart are they always in degrees? They're always 360 degrees apart. Okay? All right. Any questions there? Yeah.
Are you going to keep going reviewing?
Yep. Should I ask it now? Sure.
Oh, well, it was just the last thing that we talked about. Example 4.
Okay, the degrees, minutes, and seconds. Okay, so let's start off right there. Let's quickly review that, and then we'll finish this up right here. So if you look at example 4, it says convert 35 degrees, 15 minutes, and 12 seconds into decimal degrees. And on this one it says take this measurement, which is in decimal degrees, and we want degrees, minutes, and seconds. So the two of these are like opposites. So if we understand one, we'll probably be able to understand the other one. So here's the basic idea. If I cover this one up right here, and I have 35 degrees and 15 minutes, okay, 1 degree is 60 minutes. So if you have 60 minutes, you have a full degree. Well, we don't have 60 minutes right here, so we have a fraction of a degree. What fraction of 60 is 15? 15 over 60. 15 over 60 is 0.25. Okay, so if I just had this problem right here, if I had 35 degrees and 15 minutes, that would be 35.25 degrees. Okay, so that's why we took the 12, we converted this way. Okay, we do have this little bit of extra. That little bit of extra makes this 0.25 and a little bit more. So the way we do this is, so let me just back up and we'll run through and do this problem again. We kind of work this backward. Okay, so we're going to start with this right here, and we're going to convert that into a decimal for the minutes. So if I have 12 seconds out of 60, what fraction of a minute is that? Okay, that's going to be 0.2, right? So what I have now is 35 degrees and 15.2 minutes. So it's a little bit more than that 15 minutes that it used to be because we had these 12 seconds hanging on right here. So then I'm going to take this 15.2 minutes and I'm going to figure out what fraction of a degree that is. So I'm going to take 15.2, put it over 60, and let's come up with a decimal equivalent for that. So we'll just type that into the calculator. And if we do 15.2 divided by 60, 0.253 repeated. So 0.253 repeating. So this in minutes is this in degrees. So the whole answer is 35.253 degrees. And that's going to repeat. Does that make sense? Okay. All right. So now we're going to do the same thing just in reverse. They gave us an answer in decimal degrees. So it's all degrees, no minutes and seconds. And we want to figure out, well, how many minutes and seconds would we have if we had 56.321 degrees? So what we do is we say, well, I've got 56 degrees. I've just got a little bit more than that. So we're going to say, all right, I've got 56. Strip off the decimal part, 321. And then we want to figure out, well, how many minutes is that? So we take 0.321 and multiply it by 60. So we'll grab the calculator. Okay, notice we're going to be timesing by 60 rather than dividing by 60. So I take 0.321 times by 60. Well, that gives me 19.26. So this is 19.26 minutes. Well, I clearly have 19 full minutes, so I'm going to keep the 19 full minutes. And then I'm going to, again, strip off that decimal part, the 0.26, and I'm going to figure out, well, if I've got 0.26 minutes, how many seconds would that be? Now that's a little bit over a fourth of a minute, right? So a fourth of a minute, what would a fourth of a minute in seconds be? 15-ish, somewhere around there. So let's grab our calculator again. Let's take the 0.26 times that by 60, 15.6. So this is 15 point, whoops, times 60 is 15.6 seconds. So if I take the 56 full degrees that I had, took that decimal 0.321 times it by 60, I had 19.26 minutes, 19 full minutes. And then I take the 0.26 times it by 60, that gives me 15.6 seconds. So we have 56 degrees, 19 minutes, and 15.6 seconds. Now, can you see why they don't use degrees, minutes, and seconds very often? Okay. They're kind of a pain to work with. They're a little bit of an artifact from what they used to do in ancient times. There's a good rationale for why we use degrees, minutes, and seconds. If any of you are familiar with a nautical mile, if you're on a boat or something like that, they don't measure your speed in miles per hour, or even on an airplane for that matter. They measure it in knots. A nautical mile is 1 arc second at the equator. So if you took the entire Earth, so let's say we're looking at it from above, here's the North Pole, here's the equator. If we took a little slice that was a degree, and then broke that slice down even further, so we took a minute, so let's say this is 1 minute, and this is 1 degree. If we broke that even further, took a little slice of that, and that's 1 second, 1 arc second at the equator is how they figure out what a nautical mile is. It's a little more than what we call a statute mile. So when we say miles, most of the time we're talking about a statute mile, 5,280 feet. A nautical mile is a little bit more than that. It's around 6,000 feet. So it's about an eighth more than a mile. So if somebody was going 20 knots and somebody else was going 20 miles per hour, who's going faster? The person going 20 knots, because a nautical mile is a little bit further than that. Okay, that's one of the places where those come up, just for your information. Okay, let's take a look at the last couple problems. Are there any questions so far? We're all right? Okay, so this problem right here is just a simple subtraction problem. So we're supposed to take 76 degrees and 6 minutes and subtract 18 degrees, 54 minutes. So, pretty basic. You're all pretty good mathematicians here. What do we do first? Correct idea, Alexis. So she said transfer. What word did you learn in elementary school? Borrow. So if we had something like this, let's say I had 1,104 and I was going to subtract 597. I can't do this subtraction problem because there aren't enough ones here to subtract 7 ones from it. So I'd borrow, but there's nothing here, so I'd have to borrow here. So this is what we do. I'd make that a 0. Okay, if I take 100 and move it into the tens, that would be 10 hundreds, right? Okay, but then I have to borrow from this, that would be 9, and then I can add 10 to this, so this is 14. And now I can go ahead and do the subtraction, and I'd have a 7, a 0, and a 5. Everybody good there? Well, we do exactly the same type of things, except for we're not moving tens anymore. We're moving 60s because we're talking about the comparison between degrees, minutes, and seconds. So on this one right here, I don't have enough minutes here to subtract 54 minutes from it. So I'm going to cross this off. I'm going to make this 75 degrees. And if I transfer 1 degree over into the minute category, what is it, Alexis? I'd add another 60, so this would be 66 minutes. So I'd have 66 minutes minus 54, that's going to be 12 minutes, right? And then I have 75 minus 18, I can go ahead and do that one, that's going to be 47 degrees. So the answer to that problem would be 47 degrees in 12 minutes, that's the difference. So it's just like the stuff you learned how to do in elementary school with borrowing and all that sort of stuff, it's just in a little bit different application. Okay, any questions? Yeah. Oh, let's see, did I do my arithmetic wrong? I did. Yep, you're right, 57. Okay. I'm not very good with numbers. I apologize. Okay. Questions? Oh, that made you laugh. That's nice. Okay. All right. Any questions so far? Did I screw up anywhere else? Yeah.
Do you want us to round the seconds or just leave it as a decimal, like 15.6?
On this one right here, I'd leave it as 15.6. Yeah. That's why it's a little bit hard, because even seconds aren't a very big measurement. Okay, if you want to be really accurate, that's why we use decimals. Okay, you're gonna see this all the time. You're not gonna see degrees, minutes, and seconds again. Okay, occasionally there'll be a problem that will crop up here or there. I doubt they'd put one on the final, but every year there's somebody new at the college that writes the final exams, and it could be their pet peeve, and they may think, hey, I want to make sure these kids know degrees, minutes, and seconds. So be aware of it, but don't sweat about it too much. Okay? Any questions? We're good? Okay, let's take a look at the last one, because this one's kind of interesting. So this is problem number 88, and I believe this is on your assignment. This problem is only made difficult by one thing, the fact that this measurement has both degrees, minute, or all three, degrees, minutes, and seconds in it. If the problem had been this, and this was 40, and it said, hey, tell me what the measure of these two base angles is. First of all, remember, this is an isosceles triangle, so that means the base angles have to be congruent. Those two are exactly the same. If this one's 40, how would we figure out what those two measure?
Subtract 180 and then divide by 2.
Okay, so we're going to take 180 degrees, we're going to subtract 40, that's going to leave 140 degrees, and then what do I do with this? Okay, I divide that by 2, so that's going to give me 70 degrees for this one, 70 degrees for that one. 70 plus 70 is 140, plus 40, 180 altogether. So we got that right. The only difference here is we're going to do exactly the same steps. That took about 10 seconds to do. This is going to take a little bit longer because we've got those degrees, minutes, and seconds in it. So here's what we're going to do. Same process. I know what this vertex angle is, so I'm going to take 180 degrees and I'm going to subtract 30 degrees, 24 minutes, and 12 seconds. What's the problem here? Okay, not enough. So I'm immediately going to go to, let's go to 179 degrees. If I take a degree and slide it over to the minute column, I've got 60 minutes, but I need to borrow one here, so I'm going to make that 59 minutes, and if I take a minute and slide it over into the second column, that gives me 60 seconds. So if we take a look here, look at these red guys right here. This is a weird way to write 180 degrees, but it is. 60 seconds is 1 minute. Add that on here, I'd have 60 minutes. 60 minutes is 1 degree, so I still have 180 degrees up here. It just looks weird. Now let's do the subtraction. 48. 59 minus 24, so that's going to be 35, right? And this is going to be 179 minus 30, so that's going to be 149. Now, we're to write here on this, and that's the equivalent. What did we do next to figure out these angles down here? Okay, we divide by 2. So here's where it gets to be a little bit of a pain in the butt. I need to take this and I need to divide it by 2. So there are several ways to do this. I think this is the most straightforward. Let's just take everything and divide it by 2. That's going to give me 74.5. This is going to give me 17.5. Did I do that right? Okay. And this is going to give me 24. Okay, so at least that one works out nicely. Any questions? Okay, but we definitely don't want to have a decimal here and a decimal here. So let's figure it out this way. This is 74 and a little bit more, 74.5 degrees. Well, if I have half a degree, I can slide that half a degree into another category. So let's keep the 74 degrees and let's slide a half over here. If I slide half a degree over into the minute category, what is it? Okay, take 0.5 times 60, or just say, well, that's 30. I'm going to add 30 here. Okay, so that's going to be 47.5. Still don't like the 0.5, so I'm going to keep the 47. I like that. I'm going to take half a minute and slide it into the second category. Okay? So if I take half a minute and slide it into the seconds category, I've got how many minutes here? Okay. another 30, so that's going to give me 54 altogether. So I like the 74, I like the 47, and I like the 54 now. So what does this measure? This measures 74 degrees, 47 minutes, and 54 seconds. Now, let's talk for just a second. This is why these are not used very often. When we did this problem, this could all be done in our head. It was very easy, took about 10 seconds. This took several minutes to do. If this had been written in decimals, if this had been 30, oops, let's say this is 30.269 or something like that. Subtract using decimals, divide, that's going to produce decimals anyway, and then you're all set to go. It's just much quicker using decimal degrees than degrees, minutes, and seconds. Yeah?
So if it comes in degrees, minutes, and seconds, and can you switch it over to decimals and do it, or do you need to keep it like
No, not in this section. Okay. Yeah, the point of this section is to just get you practicing with those, but that's a good question. Okay. Anything else? Okay. Sure? Okay.